up, we're going to talk about graphing simple rational functions. So the general form for a simple rational function is y equals a over x minus h plus k. So there are some special attributes for a simple rational function. So all simple rational functions have a vertical asymptote at x equals h and a horizontal asymptote at y equals k. So for example, we have the simple rational function 1 over x minus 3 plus 2. We have a horizontal asymptote at y equals 2 and a vertical asymptote at x equals 3. Remember that the h's are always the opposite sign of whatever they appear in the problem. Everybody's okay there? So that means that the domain is going to be all real numbers except for h, and the range is going to be all real numbers except for k. Or if we want to prefer to use interval notation here, that would be negative infinity up to h union h to positive infinity. Remember, when you use the parenthesis, it's not including h, so it's everything up to h and then everything after h. And similarly for the range, would be everything up to k and then everything after k. So if you're looking for the interval notation representation for domains and ranges, they would be there. Okay, so this is pretty nice. Because again, if we go back to our example, that means that our domain is negative infinity to 3, union 3 to infinity, and the range is negative infinity to 2, union 2 to positive infinity. Pretty easy. So if I want to graph, what I'm going to do is I'm going to make a 5-point XY table. And I'm going to put the h value as my middle point. And what I like to do after that is to fill in the y coordinate underneath it, because the h here is the vertical asymptote. So the h doesn't get a point. If I plug that value for h into my function and try to type that into my calculator, I'm going to get an error. So that's not going to do me any good. And then I'm just going to pick 3 points on either side of my h. So just typically I just go up by 1s and then down by 1s. So if I'm looking at the example above here, the h is 3. That's going to be the middle point in my table. And I would just do 2, 1, 0, 4, 5, 6. To find the y coordinates, then I'm just going to plug these into my expression. So I'm going to use the calculator to help me handle that. So I'm going to press alpha and the y equals and select the numerator over denominator command so I can write it like a fraction. And I'll just start with 0, minus 3, minus 3, and then I have the plus 2 at the end. So that gives me the fraction 5/3. And if I want this as a decimal, I guess I'll just have to do 5 divided by 3. Since I'm graphing, I would prefer to have these as decimals because it's a little bit easier to tell where they're going to go. And if I press second and enter a couple of times, it will recall the last few things that I typed in. And I can just go back in and edit the 0 to a 1. That gives me 3 over 2. That one is easy to do in my head. That's 1.5. And then change that to a 2. That gives me 1. Remember, this is just kind of filled in. That's my vertical asymptote, so no y coordinate goes with that. And I'll go back in and change this to a 4. That gives me 3. And I'll change it to a 5. That gives me 2.5. And then change that 5 to a 6, which is 7/3 or 2.3 repeating. And if I look at this closely, you notice there's a pattern. So in between these two is like 1.6 repeating. In between these is a half. In between these ones is a half. And in between these ones is 1 or 0.16 repeating. So my graph the point should look kind of symmetric. All right, let's draw us a picture. So the first thing I'm going to do is draw in my asymptotes. So I have a vertical asymptote at 3. And I have a horizontal asymptote at 2. And now I'm going to plot my points. So I have 0 and 1.6 repeating. And I have 1 and 1.5, so just a little bit lower. And then 2 and 1. So I'm going to draw a line going through these 3 points that also follows my asymptotes. So I'll be starting following the horizontal asymptote, and I'll end following the vertical asymptote. And I have arrows at both ends. And then I'll draw my other 3 points. So I have 4, 3, and then 5, 2.5, and then 6 and 2.3. And again, I'll start by following my asymptote, draw through my points, and end following my other asymptote. And that's it. So that shouldn't be too bad. If I want to check to make sure I've done this correctly, I can graph this on my calculator. So I'll just press the y equals button, clear out whatever I have here. And then I like to use, again, this fraction option. To get to here, I press alpha and the y equals. I choose option 1. I'll do x minus 3 and then plus 2. And I will just use my standard window, so I'll do zoom standard. Not sure what I did last time, so it's very possible I had a weird window there. But this gives me just the normal -10 to +10 window. And this is exactly what I'm seeing, right? I have my vertical asymptote here at 3. Doesn't look like the graph is crossing that. My horizontal asymptote here at 2. And we have the 2 arms of my graph. So we call each one of these pieces an arm. Okay. So there's another way, though, that we can represent a simple rational functions. And I'm just going to abbreviate simple rational function as SRF. And that is ax plus b over cx plus d. So in this case, the vertical asymptote is going to happen when the denominator is equal to 0, just like it did for the simple rational function up here. So the denominator is going to be equal to 0, at negative d over c. And the horizontal asymptote is going to be the leading coefficient over the leading coefficient. So let's look at an example then. So, to get the vertical asymptote, I'll just set the denominator equal to 0 and solve. And to get the horizontal asymptote, I'll do leading coefficient over leading coefficient. So there's my horizontal asymptote. Okay, so I'll start now by making my XY table, and I'll start doing this the same way that we did before. So I'm going to put the vertical asymptote in the middle. And I'll do 3 points on either side. So I'll just pick them in kind of the obvious fashion. And then I'll go to my calculator to help me generate the y coordinates just by plugging these in. So again, I like to do alpha and y equals. And I have 2 times x plus 1 over x minus 3. So that's negative 1/3. So I'm just going to write that as negative 0.3 repeating. And then I'll press second and enter. And I'll go back and change my zeros to ones. So that's negative 1.5. And now I'll change my 1s to 2s. Well, some of my 1s to 2s. That other plus 1 was part of the original function. So that one's negative 5. Now I'll change my 2s to 4s. Oops. Well, not all of my 2s. That first 2 was part of the function. It's 9. Now I'll change my 4s to 5s. So that's going to be 5.5. And then I'll change my 5s to 6s. Oops. And 13/3 is 4.3 repeat. Okay, so let's draw our graph now. I draw it a little straighter. That's a little better. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. And again, I'll draw in my asymptote. So my vertical asymptote was at x equals 3. So we're going right down through 3. And my horizontal asymptote was at y equals 2. So go on right there through 2. And I'll draw my points. So 0 and negative 0.3, 1 and negative 1.5, 2 and negative 5. This one's going to look like something like that. It probably shouldn't look so lumpy there through the middle, but you know, as you guys know by now, drawing with the stylus isn't easy. So there's 4, 9, then 5, 5.5, and then 6, 4.3. So again, we'll try to draw through those points, following the asymptotes. So our graph should look something like this. Probably want to list our domain and range also. So the domain, if we're doing interval notation, should be -infinity to h, union h to positive infinity. Again, that means everything below the h and everything above h. And the same thing with the range, so -infinity k, and then k to positive infinity. And these aren't really h's and k's, but they're the vertical asymptote and the horizontal asymptote. Right, that's what those numbers are. But that's basically it. So that should be pretty easy to handle, guys. There's not a lot going on there. So that should be good. After you've watched this video, you should work on worksheet 4 from chapter 9.